Hey everyone! In this last video, we are going to do an example that deals with population proportions. So, a telephone company claims that 20% of its customers have at least 2 phones. The company selects a random sample of 500 customers and finds that 88 have 2 or more telephone lines. Using a 0.05 significance level, test the company's claim. All right. So, because this is a population proportion, you can see we're going to do a little bit different. First step's exactly the same. Establish the null and alternative hypothesis, except this time it looks a little bit different. We use the p equals and the p doesn't equal, or is less than or greater than. Then our p-values, all of this stuff works where it says or proportion or p. That's what we're talking about. Okay? And then the only difference is, how do I find my p-value? Well, here are the steps to finding the p-value. We need to, so when we get to that part, I'll come back to this. But remember, we can only use this if NP and NQ are greater than or equal to 5. Your book says 15. Statistics is still being all worked out. So in some places you'll see slightly different tests for things, such as in your book, I think it says that a large sample is anything bigger than 30, and 30 is included in a small sample, but other places 30 is considered a large enough and under 30 is considered small. Statistics is still in its infancy, so there's a lot of differences from one place to another. But I do want to know what P is, what Q is, what N is, so that I can test that NP and NQ are greater than or equal to 5. So in this case, P is going to be the proportion that we're given, so that's 0.2. Q is going to be, that's our probability of success. It's going to be 1 minus that, and Q is my probability of failure, and then N is 88. Oh no, N is 500, sorry. And so NP, 500 times P, gives me 100, which is greater than 5 and 15. And NQ is 400. Again, that meets the requirements that we need. So now that we know we can do a regular test using our norm.dist function, we're going to go ahead and do that. So what I need to do is set up my null hypothesis and my alternative hypothesis. My null hypothesis is going to be that P is equal to 0.2, which is the claim. And then the null hypothesis would be that P is not equal to 0.2. In this case, it doesn't say that we're doing greater than or less than. We're just saying that it's not 20%. So then I need to find P hat. So P hat is going to be the proportion for my sample. In this case, that's the 88 over 500. And you can see that in here, that's this P hat is X over N. So X is the number of favorable outcomes. In this case, 88 out of 500 is 0.176, which is less than 0.2. So P hat is less than my population proportion. And so when I go to calculate the probability that P hat is less than 0.176, and why am I using less than? I'm using less than because we always want to go away from mu. So mu, or P in this case, is 0.2. Since this is less than that, I'm going to go less than. And so, And so what we're going to do is use the norm.dist function. And I'm just wondering, what's the probability that this value could be less than this value? given a certain standard deviation. Do I have the standard deviation? I don't have it yet. I need to calculate that. Okay, so let's take a step back for a second. I don't have the standard deviation yet, or the standard error, so that's something I have to calculate. But we have a formula for that. The standard error is the square root of PQ over N. So that's going to be the square root of P times Q divided by N, and that comes out to 0.018. So now I think we're ready to find our p-value. Since it's less than, I can just use norm.dist. Again, here's my sample mean, or my sample proportion. Here's my population proportion. Here's my standard error. And then we write true, and we get 0.089. Since it's a two-tailed test, I'm going to take 2 times that proportion, and we get 0.18. So that is significantly bigger than the 0.05 that I was looking for, and therefore we will fail to reject the null hypothesis. So there is not enough evidence to suggest that a different amount other than 20% of customers have at least 2 phone lines. So what we've done is we've actually we have verified the claim by the telephone company. So sometimes the thing that somebody claims is our null hypothesis. Sometimes the thing that's claimed is not our null hypothesis. But this sentence works for anything. There's not enough evidence to suggest that there's a different amount other than 20, which in this case was the claim, and so we have verified the claim. So now let's go ahead and construct a confidence interval for this. It's a 95% confidence interval. Since we failed to reject the null hypothesis, I would expect that this the confidence interval would contain P, our original P of 0.2. So we're going to use the sample P hat and the standard error, and we're going to find a lower bound, and we're going to find an upper bound, and we can do this just using our norm.inverse function. Again, this is all spelled out. Creating a confidence interval is the same. This is two-tailed, so we're going to use norm.inverse, and we're going to do alpha divided by 2, comma, p hat, comma, standard error, and that'll give us our lower bound, and then we're going to do the confidence level plus half of alpha. So alpha is 0.05 because this is a 95% confidence interval. If we cut the 5% in half, that's 2.5% or 0.025. So we're going to take 0.025, comma, p hat, comma, standard error, and there's my lower bound. My upper bound is going to be norm.inverse. I'm going to take the 95%, 0.95. I'm going to add 0.025 to it, comma, p hat, comma, standard error, and that gives me 0.211. So this is my lower bound, this is my upper bound. Since 0.2 is contained within our confidence interval, we will fail to reject the null hypothesis. So we're just verifying the claim that we made here to reject failed to reject the null hypothesis by constructing this confidence interval. All right, I hope these series of videos, along with the overview of everything that we've done, this kind of cheat sheet here, I hope this will help solidify all the ideas we've been talking about for the last 5 lectures or so. And this serves as a little bit of a review for the 4th exam that we're going to have. So work through these problems, work through the problem set, and I'll see you in the next one.